Section 6.5 is a general factoring strategy. So we're going to talk real briefly about how to identify what type of polynomial we're looking at and what types of factoring I may need to do. The first and most important thing to check for anytime I'm trying to factor a polynomial is there a GCF? Is there something that's in common that I can factor out of the entire polynomial? This step is so important but so easy to accidentally skip and just start trying to identify the type. It's very important to notice if there is a GCF that you can take out first. It's going to make your life a lot easier when you're trying to factor this, and it may make the factoring strategy that you're going to choose later different. Okay. After checking for a GCF, the factoring strategies are broken down by the number of terms. If there are two terms, then hopefully it's a difference of squares. If it's a difference of squares, this will factor into binomial conjugates. So A plus B times A minus B. If it's not a difference of squares but is two terms, a GCF may be the only way to factor it. There are also types of factoring that involve differences of cubes, which are covered in Math 131. If there are three terms, there are going to be two types for us. If there are three terms, the type with coefficient 1 and the type with coefficient not 1. If the coefficient is 1, we're going to be looking at the end number c, trying to factor that to find two numbers whose sum is b. If the coefficient is not 1, we can factor by trial and error, looking at a combination of a and c, trying to add to b, or by grouping, multiplying a times c and trying to add to b. If there are 4 or more terms, we're going to have to use the grouping method. Grouping is the only method that's going to work on a polynomial of 4 terms. When I say 4 or more, it does need to be an even number, so you can split it evenly into two groups, so 5 terms wouldn't apply, but 4, perhaps 6, would fit into this grouping category. For the most part, if we're going to be focusing on 4 for our grouping strategies. Okay, so the breakdown of factoring is split into those three categories. The categories where there are 2 terms, the categories where there are 3 terms, and where there are 4 terms. Now beyond that, once I've factored something one way, I may have to factor it again. So I'm going to factor it and then check each of the factors to see if that they are completely factored. If they can be factored further, I'm going to factor them some more. Okay, so I need to make sure that they are completely factored. And then I can always check my answer. So if you're on a test or a quiz, you can always check it just by multiplying them back together. There's no need to ever get it wrong. You can just know that you've done it correctly by checking. Alright, so let's talk about some of these strategies in terms of an example. In this first example, I'm looking at these numbers. I'm going to follow my steps. The first step I say, is there a GCF? I notice, yeah, 7 goes into both of them. Since the leading term is negative, we're going to factor out a negative 7 as well as an x because they have an x in common. When I divide out that negative 7, I'm left with just an x in the first piece. In the second piece, I'm left with a negative 5. No x, I've already taken that x out. Okay, can x minus 5 be factored further? There's nothing in common. There's no x squared to break it down. Remember that these different types right here were types for specifically quadratic polynomials, but they needed to have degree 2 in the parenthesis right here or higher for me to be able to break this down further. So this one is done. Okay, that's factored. Okay, in the next one, alright, is there a GCF? Can I factor a number out? No. Okay, no number goes into 25 and 49. So let's look how many terms there are. There are 2 terms. So if there are 2 terms, I'm going to check, is it a difference of squares? Are these perfect squares? And yes, they are. So I'm going to factor this as 5x plus 7 and 5x minus 7. The binomial conjugates here, because 25 and 49 are both perfect squares, the difference of 2 perfect squares. Okay. Part C, there is no number that I can divide all of these by. They don't all have an x, they don't all have a 5 or a y, so I can't take a GCF out, so I'm on to how many terms there are. There are 4 terms, so if it's 4 terms, I'm going to try grouping. Let's go ahead and group into 2 groups here. The first group has a 5 in common. If I take that out, I'm left with x plus y. The second group has an x in common. If I take that out, I'm left with x plus y. Now it's only halfway done. X plus y is common, so I'm going to take that out. And when you take the x plus y out of the first group, you're left with a 5. Out of the second group, you're left with a positive x. So the final answer is x plus y times 5 plus x. Alright, in letter D, I look for a greatest common factor. There's no number that divides evenly into all of these. Then I think about how many terms I have. I have 3 terms. The coefficient is not 1, so I'm going to either try factoring by trial and error or by grouping. So I'm going to use trial and error here. The only way to multiply to 3 is with 3 and 1, so it's going to have to be 3 times x and 1 times x in my first positions there to make that 3x squared. Now the only ways to make 2 are 1 and 2. I'm not sure if it's going to be 1 then 2 or 2 then 1, so I'm going to try each of these. Let's try 2 then 1. Let's think about signs real quick. Positive and positive, so they're both going to be positive. So let's check. That gives us 3x plus 2x, which adds to 5x. That's not correct, so let's get rid of 2 and 1. And let's try 1 and 2. So this gives us 3 times 2 is 6x, and 1 times x is x, which adds to 7x. That is correct, so we found the right answer. Okay, so we had to try that one twice by using the trial and error method. Okay, just checking to make sure. Again, when I check this, 3x times x is 3x squared, 3x times 2 is 6x plus 1x to add to 7x in the middle, and 1 times 2 is 2, and all my signs work out, so there we go. Okay, let's go to the next page. Okay, I've got a couple more here I'm going to use the general factor strategy on. When I look at the first one, there are 2 terms. Is there anything in common? Yes, 7 is in common, and so is x. So I'm using the GCF, taking that out. It's going to leave me with x squared plus 1. Okay, can I factor x squared plus 1? It's 2 terms. I do have a squared, but it's not a difference of squares. So a sum of squares is prime, so that means this one is done. The answer is not prime because I did factor it a little bit. So I'm done. I'm factored. I can't factor any further. Go on to the next one. 3 terms. There is something in common, so I'm going to make sure I take my GCF out first. Divide everything by 5. Alright, I need to continue to factor. This right here, the x squared minus x minus 6, is a trinomial, 3 terms with coefficient 1. So I just need to break up the 6 here. Try to get it to add to negative 1 in the middle. 6 is negative, so I'm going to need a positive and a negative. It's going to end up being negative, so the negative number is larger. So what goes into 6? We have 3 and 2. We said the negative was going to be larger, so a negative 3 and a positive 2 to add to a negative 1. So this will factor into 5 times x minus 3 and x plus 2. Just bringing that 5 straight down as part of the original factoring, and then breaking this trinomial into these 2 parentheses. Alright, in part C, the next one, it's 2 terms, and there looks to be something in common. I've got 2 that can go into both of these, so let's start by taking that 2 out. If I divide them by 2, I've got x to the 4th minus 81. Now it's 2 terms, so if it's only 2 terms, I'm trying to see if it's a difference of squares. 81 is 9 squared. X to the 4th is x squared squared, so we do have a difference of squares, so we're going to factor this into x squared plus 9 and x squared minus 9. Now we have an x squared in each of these, so we're going to check to see if it can be factored. 2 terms, both squares, but sum can't be factored. 2 terms, both squares, difference, that can be factored. So I'm going to leave the x squared plus 9 alone. I can't factor a sum of squares. I can factor the difference of squares into x plus and minus 3 because 9 is 3 squared. So it'll be x plus 3 and x minus 3. Be my final factorization. Okay, D, there are 4 terms. You cannot divide them all by some number, so we're going to go right ahead to 4 terms means use the grouping method. The first 2 terms have an x in common. When I take the x out, I'm left with y minus 7 plus, I can divide these both by 3, so they have a 3 in common. Divide by 3, I'm left with y minus 7. Now y minus 7 is a thing in common, and what's left is x plus 3, and that's factored. Okay, and the next 2 here, E and F. E is a trinomial. There is something in common. They can all be divided by 7 and by y squared. Okay, when I take the 7 and y squared out, I'm left with y squared plus 2y plus 7 divided by 7 is 1, so plus 1. Alright, what I'm left with here is a polynomial coefficient 1, a trinomial coefficient 1, so we're going to continue to factor that. 1 is 1 times 1, so if I add those up, I get 2, which is what I wanted to get. So when I factor this, it's going to be 7y squared, just bringing that down, times y plus 1 and y plus 1. Alright, now because I have y plus 1 written here twice, I can write this simpler as 7y squared times y plus 1 squared. Okay, and letter F, 16, 28, and 30 can all be divided by 2, and all 3 terms share an x. So let's take out that 2x. That'll leave us an 8x squared plus a 14x minus a 15. And because 8 can be broken down in a variety of ways, 1 and 8, 2 and 4, and so can 15. It can be 1 and 15, 3 and 5. Let's go ahead and use the grouping method on this trinomial with coefficient not 1. So let's go ahead and use the grouping method. So I first need to figure out what 8 times 15 is. 8 times 15 is 120. Okay, so let me take that 120. It's going to be a negative 120 because of the negative 15. Because it's negative, I know I'm going to need a positive and a negative, and the positive is going to have to be larger. Okay, so 120 is 12 times 10, so 12 minus 10 is 2. Not big enough, I need it to be 14. Okay, so let's go bigger. Let's try 24 times 5 is 120. So 24 minus 5 is 19. So it looks like I went too big there. So the number I need is between 12 and 20. So let's grab our calculator. So we just did 24 times 5 was 120. So now I need to go smaller. Let's try 20. 20 goes into 126 times. So 20 minus 6 is 14. That's what I want. So I'm going to get rid of the other ones. This is going to turn into 8x squared instead of the 14x. We're going to write plus 20x minus 6x minus 15. Then we're going to group. We can divide these both by 4x. 8 divided by 4 is 2x. 20x divided by 4 is 5. Minus 3 can be divided into both of those. It's going to leave us with 2x plus 5. Negative 15 divided by negative 3 is positive 5. So they have a 2x plus 5 in common. It's going to leave us with 4x minus 3. And don't forget this 2x right here has to come out in front for our final answer.